Let's talk about FPV gear. So I decided to go with 5.8. One of the greatest things about 5.8 is that it's dirt cheap if you go to Hobby King. They have a 5.8 system that comes with this transmitter, this receiver, a couple whip antennas, and the wiring to get you going. And it's everything you need as far as transmitter and receiver to get going with FPV, and they're actually decent units. This receiver is a really nice receiver. I think I've had great luck with it. It will run off 12 volts. I don't recommend you run them off 12, but this will run off 12. The transmitter definitely runs off 12 volts, and it does so really well. It has an input for 12 volts and then output for 12 as well, so it'll power your camera. They come with RP-SMA connector, so that can be problematic if you're buying pre-made antennas. However, you can get adapters for RP-SMA to an SMA connector, which is what I have right here. These are like $2 at SparkFun, and that fixes the problem. This unit comes with antennas itself, which is a whip antenna just like this one. The only thing these are good for are either throwing in the trash or busting them apart, and I have a video on how to do this, bust them apart and turn them into either a cloverleaf antenna or a circular polarized antenna or a helical antenna for your receiver. So that's all this is good for. The one with a 90-degree angle on it is pretty much good for nothing because you can't really get to the inside coaxial wire reliably. And what you do get is just a stub. It's not very long. Okay, so this is what we're going to be using. For my receiver, you notice I have a couple wires coming out of it. These have a regulator inside that steps the voltage down from 12 volts in all the way down to 5 volts. So these actually run really hot, and I've had 2 of them where the voltage regulator has burnt up on me. So what I do now is if I'm going to run a receiver like this, I actually pull these open and I bridge the voltage regulator, and then I solder on a ground and a power and come out, and then I just use 5-volt U-back to power the system. U-back with the receiver runs much cooler. You bypass the voltage regulator, runs cooler, and I don't worry about the signal dropping out from the receiver burning up on me. It's not a hard mod to do. I'll probably make a video sometime how to just pop this apart and then bridge the voltage regulator and add a couple wires. The transmitter, this one has a capacitor soldered on, and I'll explain that in a minute. So let's go over a couple things first. First off, the antenna part, like I said, this is only good for testing, and it's only good to make another antenna out of it. Other than that, it's fairly shitty. So don't even try to fly with this. I mean, second, let's go ahead and do some wiring. I'm going to hold it up like this. So when we're looking at the connector, the power in is the small 2-pin connector here. And the power is on the outside closest to the edge of the PCB, and then the negative is on the inside. Simple. On the other side, on the very outer side closest to the PCB, this is actually the ground wire. Then the next pin, the second pin from the outside, is the power wire that will go to your transmitter or to your camera to power it. The third wire in is the signal that comes from the camera as well. That's the signal in. The fourth wire, I believe, is audio, and then the fifth wire, I don't know, I never use it. I actually don't use audio either. I don't understand why you'd want to hear your motor or wind rushing, but never once have I crashed and said, well, if only I could have heard it, I would have been able to not crash. Anyway, ground, power, signal. from this outside edge, ground, power, signal, then audio, if you want to use it. On the power side, it's power, then ground. A little confusing, but you'll get it. As far as channel selection, this is an 8-channel receiver, 1 through 8. Most, or I don't know most, I always run it on 8 because it's easy to remember. It's just all up. And then on the transmitter, it's all down except 4, which is up, which doesn't actually matter because 4 is not tied to anything. On the inside of the receiver on the transmitter, I do believe there are 3 channel selection pads and then a ground, and that's how we make our selection. 4, if you notice, if you get this, you'll notice that 4 is up on every channel combination. That's because it doesn't matter. It's not tied to anything. Okay, so you see this has a big fat cap on it. This is a 470 microfarad 25 volt capacitor. What this actually is part of a LC filter. L, I believe, stands for inductor, C, of course, for capacitor. So it makes an LC filter, and this is my power wire. I run a separate flat battery, 500 milliamp, 3-cell LiPo, little guy. And that powers the transmitter, and then the transmitter powers the camera. Well, the wires run, these wires run close to other power wires or other speed control motor wires, and it can pick up the pulsing signal and create a noise that comes through. Or if you're running this straight off your main flight battery, it can pick up the different signals that is being created from the speed controls pulsing and pulling current from the main battery. So all this is a filter. You take a ferrite core, you wrap your power wires around it as many times as they go. This is the L part. This creates an inductor. Plug this in, and then in front of that should be the capacitor, LC filter. Well, usually people would split right after the inductor and do the capacitor across the 2 wires. Perfectly fine to do. I thought it was a cleaner installation to just come on the back of the transmitter and find the 2 stub ups for the power cord, power wire, and it's soldered on back here. So this should remove the white lines that people see in their video or see in videos sometimes. It runs across, kind of looks like Venetian blinds or blinds, window blinds. That's what they actually call them. Let's talk about cameras for just a second. The camera I do use is the Security Cam 2000, part number PZ0420N, and it comes with an OSD board, some cables that you're not going to use, and a 3.6mm lens. I have taken the opportunity and purchased as well this little metal case from Security Cam 2000. Usually I fly with the cam on a pan tilt, and I fly with a 3.6mm lens, and I use the pan and tilt to allow me to see forward when I'm doing fast forward flight. You know, on a quad, you tilt like that, you're looking at the ground, you can't see in front of you, but with the pan tilt, it tilts up just enough so I can see in front and still maintain my forward flight. I got tired of the pan and tilt because it's just an extra thing I have to worry about. So I went ahead and ordered the 2.8mm lens, and that gives me more viewing area. And since I wasn't going to be running the pan and tilt anymore, I decided to try this little case. And I got to tell you, I like it. It adds a bunch of protection to the camera. I have lost a couple cameras from crashes, and it sucks because they're not completely protected. I feel like this is going to protect the camera greatly because you actually remove, where this lens screws into is a plastic base, and that fits over the filter. Well, with this case, you actually remove that plastic base, and the case becomes where the lens screws into, and then the entire board and sensor is protected by pretty hefty metal. I don't know, I guess it's cast aluminum maybe. I feel like this could survive a pretty good crash, and the only thing that would really get damaged is the lens would break. And lenses are $7. I'd rather lose $7 lens than a $45 camera. It has the cutouts for the OSD and for the power and video wires, which is nice. This security cam, I don't know if they're doing this now because a lot of people are using them for FPV, but it comes with a spare cable now that's fairly long for your ground power and video, and then you can put your own connector on one end. When I bought my first one, it just came with this, and I had to cut this off and then just use a stub. But it's nice that they're including that other wire now. So that's what I have on mine, is the original stub from the other cameras that I've had. They've all been destroyed. This is the one that I have now, other than my $16 camera, but still using the same connector. And I basically just put a new servo end on it, and then on the other side I use a male servo ends. So I got the 3 prongs, and then, you know, just hooks up like that. Piece of tape around it to hold it, and I'm good to go. But I really like this case. It is, the downside, it's heavy. It's 43 grams, so it adds a little bit of weight, but I'm willing to sacrifice the lightweight for the increased durability for the camera. I'm tired of tearing the cameras up. And then as far as quality, this camera, it's hard to beat. It's a really nice picture. I enjoy flying with it a lot. If I wasn't flying with this camera, I'd be flying with the TBS 69, which is, it's like a $170 camera, but it's amazing. This to me is the next best thing. So that's my camera, my flight camera. Antennas. I have a how-to video on how to build this antenna right here using the stock whip, some 14 gauge wire, piece of dowel rod, and some galvanized metal. A little bit of plastic, some Velcro. Makes a 3-turn helical that, you know, it's pretty decent. Gets you semi-long range. You're not going to break records with it, but it'll get you out far, pretty far. So if you have any, you know, if you feel like running a helicoil, then by all means check the video out. But this is one option that people can use, the helicoil. It's a directional beam. I believe this has 150 field of view, field of radiation. So it's pretty wide. You can fly behind yourself with it, but not very far before it starts breaking up significantly. But this seems to penetrate through trees and walls a little bit better than. It's not bad. I like it. Easy to make, cheap to make, and you can really perfect them. I know people have set records with the 12-turn of this 12-turn version of this. It's like that long, dude. It's pretty long. Anyway, they've set the distance record on 5.8 with a helicoil antenna like this. For the transmitter and receiver, I normally run the Cloverleaf. The Cloverleaf is the transmitter. It has an overall higher gain. I have a video on how to make one of these as well. There's tutorials on RC Groups. I use RG316 coax cable. I use 023 meg wire, and then for the receiver, I run the skew planar wheel, which is a 4-lobe instead of 3. And I run it on a little bit longer coax cable because I actually fly with goggles and I want this to be able to pop above my head. And this is a combo where I run. I make them myself. I pay a little bit more. I pay $11, $12 for the wire, but it makes 2 antennas, so $6 each. So you're looking at $12 a set versus like the cheapest set is like $40. It's worth a shit. So that's what I use for antennas, and this is the only thing I would recommend for antennas. You either need to buy a set or you need to make a set. I have a video on how to make them. There's tutorials on RC Explorer. There's tutorials on RC Groups. There's tutorials on FPV Lab. There's a tutorial somewhere that will show you how to make these, and they are the greatest thing since sliced bread. Grats, Old Man Mike, and I Be Crazy. For receiving, for what I view through, I like to use the old Googles. I get the Fat Shark bases. They're $249. And since I don't want to be tied to a ground station all the time, I went ahead and integrated a 5.8 receiver, 5.8 gigahertz receiver inside the goggles, tied into the 5-volt voltage regulator that's internal to the Fat Sharks. And this is what I fly with. I don't think I would be able to fly FPV without these. This made the world of difference for me. When I was flying with a monitor, I didn't like it very much and probably wouldn't have stayed in the hobby. But I wanted to try the goggles because I kept hearing about full immersion, and my God, were they right. This makes a world of difference for flight. And with the helicoil, a little Velcro, right? Do this. You got your directional, long range, good penetration. Or if you're going to be flying above yourself and all around, we get with the longer wired skew planer. Throw on there. And then you just got some good all around flying. Use a Futaba plug that fits in here. And then I have put a barrel plug on that actually fits into the charge port of my 9X. Have an on-off switch here that controls a UBEC that's internal, 7.2 volt UBEC. This plugs in here. Flick the switch, that gives me power to the goggles and to the receiver, so then I can view. And then what's nice is while I'm doing all that, with the 9X it has a voltage meter, so I can monitor the voltage of my transmitter pack while I'm running my Googles. And this is a great, I think, is a great setup for me anyway, because it allows me to take my Googles, take my radio in a quad, and go fly. This is not something that, you know, a beginner needs to do, somebody just getting into it needs to do, but man, if you get the feeling whatsoever, goggles should be one of your first investments. It really does open up your eyes to what FPV can be. And then the last thing that we really should talk about is going to be an OSD. OSDs are not necessary, and I didn't fly with one for a long time until we started wanting to go kind of long range with an airplane, and we got a OSD simply for the fact of having the GPS and the home arrow so we could find our way back. Don't need one. However, a very simple OSD from Hobby King is a great piece to have. It's $8, and all it displays is voltage and the time that it's been running. With a quadcopter, it's pretty important that you land before you drain the battery, because especially if you flash your speed control, you don't have that low voltage cutoff anymore. It'll just run the pack down until you kill the pack. So it's really handy to have at least a voltage, an OSD that shows voltage, and then the time's handy too, because, you know, I like to see how long I've been flying. This is a really simple unit. It can actually see 2 batteries, so you can do the main flight pack, and then you can do your OSD, or your video transmitter, your video system, whatever you want to call it, battery if you're running 2 batteries. I don't care about this one because this 500 megahertz, this 500 milliamp will run the transmitter and camera all day. I don't have to worry about it. With this, the power input comes in, and we're tying it to the main battery pack. Like I talked before, the main battery pack can induce signals that have a certain frequency that show up as noise in the video. So what I've done, and I can't be sure that this matters or that it would actually get through to the video side, but what I've done just in case is I've done another LC filter, inductor capacitor filter, on the power into the OSD from the main flat pack. Iron ferrite ring wrapped around creates an inductor. Here's our 470 microfarad capacitor, 25 volts. And then I solder these connections. I don't want to trust, so with my video on these pins with a servo connector. I've had some slip off and lose video on me, so I've gone ahead and soldered these together, and it seems to work much better for me, and they're easy to unsolder. So on this side, the power comes in, and you can actually look on the back of the board if you don't have a wiring diagram, and it says BAT plus, that's the positive. You need to also realize that the main battery signal needs to go into the one where it has, I want to say it's a voltage regulator of some sort. I'm not sure what it is. It's a black crystal looking circuit. I mean, it looks like a miniature voltage regulator to me, and it may be. But that's where the power needs to come in from the battery. Not on the other side where it has a series of resistors, but the one that has what looks like a voltage regulator. That's where the main power comes in. On the other side, this is the crystal. The crystal of the entire, well, it's the crystal. It's what regulates the speed of the processor. In line with that crystal is where the video and the ground from the camera come. The ground has to be used in this. I know some OSDs allow you to just bring a crystal or the signal in and then signal out and it'll work. This one doesn't. This one needs a voltage reference from that ground. So you have to use the ground of the camera and the signal. And all it does is the ground from the camera comes in, the signal of the camera comes in, then the ground of the camera comes out, the signal of the camera comes out, and then this goes to the transmitter. And I have gone away with the stock connector that they use, and I just use a servo connector that I make. And then I remembered that the signal goes to the inside and the ground is the out. And I just plug it in. It's a real snug fit, and it's never coming off on me. And if you think it might, you put a dab of hot glue on it to hold it. Then on the other end, just a cable to the camera. Again, it's just a male 3-pin, plugs into the camera, and then I take Scotch tape around both of those, and that holds it together firmly. Some people will run a capacitor on the signal wire, and what they do is they go from the signal into the negative of the capacitor, out of the positive, I believe, to the transmitter. Or that might be reversed, I'm not sure. And they sell to help clean up signal on from the camera to the transmitter. Yeah, that's probably true, but I haven't found the need to do that yet. I do keep my wires twisted to help, and I make sure that I filter the incoming power on both the OSD and the transmitter really well, and then I hope that just running the wire, signal wire and what have you from the camera to the transmitter and having that twisted, plus I try to route it as far as away from the speed control and speed control wires as possible. I haven't had any problems. I haven't had any power lines or any lines showing up in my video, and it's worked really well. If I do have an issue, then I might start using the cap on the signal, and you can if you want. I just don't see the need for it right now. So it's pretty easy. You have transmitter, power in to power it, then this sends power out. This plugs to the camera. So it gets power and its ground, powers it, and then the signal comes back into the OSD, out of the OSD, back into the transmitter. Transmitter transmits it to the receiver picks it up, then that goes to the monitor or goggles. And that is all I run.